Hi, welcome to this video in which we will show you how graphene is positively impacting solar PV systems. On this channel, Synergy Files, we aim to inspire budding engineers and technicians for a better, more sustainable world. Subscribe to the channel for more such videos. Help our channel grow by hitting the like button. Graphene, as we all know, has been cited as the miracle material. It is one form, or more scientifically, one allotrope of pure carbon. Its remarkable properties have opened up several avenues of research. Graphene is a single atom layer thick sheet of carbon, so essentially it is a 2D material. It is very flexible and efficient thermal and electrical conductor. It also has very high strength and is optically transparent. This makes it extremely interesting material for scientists, as there are many materials that are conductive but they are not transparent, and for this reason graphene lends itself for application in photovoltaics. At present, several different variations of graphene based solar cells are being researched. Even for the best of students, it is difficult to read the scientific journals and get the measure of various strands of research because of the terminology, and so we have broken down the jargon in this video and will present the ongoing work in an easy to understand language. There are three main areas where graphene is helping solar panels push the boundaries of performance. The first is their use as electrode or charge carriers. The second is their use as photovoltaic material. And third is their use as a charge holder. We'll discuss each of them individually. First, we look at graphene's use as an electrode or a charge carrier. The relatively higher electric conductivity of graphene is widely known. For a semi-metal, it has an impressively low resistance value of 3.1 microohms per centimeter square. This sounds even more astounding when you consider that graphene is a two-dimensional material. If you look at an ordinary solar PV cell, then we find metal strips covering it. These strips, or mesh wires, are there to collect the free electrons knocked out by the sun rays. There are two disadvantages of having these strips. Firstly, they do not cover all the areas for collecting the electrons, and there is a reason for that, which is in fact our second problem. The rays of sun are blocked by these metal strips on areas covered by them. This mesh of conducting strip sits right at the top and can block up to 5% of the sun rays reaching the PV cell, which reduces the overall output. This is exactly where graphene fits in. It is transparent and it can collect electrons knocked out by the sun rays, thus improving the overall efficiency of the panel. Also, the layer of graphene is flexible and thus is ideal for organic solar cells whose unique selling point is their flexibility. Graphene is also an indispensable material for panels that require flexibility as well as transparency. At present, indium tin oxide (ITO) is widely used. Although this material is conductive and transparent, but it is stiff and brittle. It cracks up when the cell is flexed, and therefore graphene is an ideal replacement as a flexible electrode. It has to be further noted that ITO is expensive, as only 5 grams of it costs about $200. It can also cause damage to the organic layer and the oxide layer, which is very sensitive to wear. On the other hand, the bonding with graphene is more natural and smooth. In short, graphene can not only be used to improve ordinary silicon solar cells as an electrode, but also it can be used for transparent and flexible solar cells. Next up, we look at graphene's use as a PV material. Now, we understand that almost all solar cells are based on the combination of P and N-type semiconductor material. There is a new breed of PV cells emerging that are based on Schottky junction diodes. This is an attempt to increase the efficiency of solar cells by using slightly different process than P-N-type cells and adding an impurity energy level in the band gap through the use of new materials. And one of these new materials is doped graphene. It has been reported that graphene silicon Schottky cells have reached efficiencies of 10.69%, while graphene perovskite cells have surpassed efficiencies of 20.3% in lab tests. Finally, let's now examine another use of graphene in solar cells as a charge collector. The third main area of research for graphene in PV is its use as a charge-holding parallel plate, just like in a capacitor. Scientists from Ocean University of China have been working on harnessing the power of rain through solar panels. As we all understand that rainwater is not pure and it has positively charged ions of sodium, calcium and ammonium. A layer of graphene is placed on the top of the solar cell not as a current collector but as an ion holder and a separator. The solar panel is sandwiched between the layer of graphene at the top and ITO and plastic at the bottom. What happens is that the positively charged ions bind to the ultra-thin layer of graphene, forming a double layer, technically referred to as a pseudocapacitor, with the electrons already present. The potential energy difference between the two layers is strong enough to generate an electric current. So far, the energy conversion efficiency has reached 6.3%, but it is the ability to generate electricity come rain or shine that is the exciting prospect of this technology. In other words, we can now create an all-weather solar panel courtesy of graphene. So that's it. We have tried how graphene is taking solar cells to the next level. Obviously, the cost of extraction of graphene is a stumbling block, but not one that can be overcome